In temperate climate zones, the year can be divided into at least two seasons, hot summer months and cold winter months. But closer to the equator, where it stays hot year-round, it makes more sense to divide the year into wet and dry seasons, based on how much rainfall there tends to be in each month. This is quite different to how temperature-based seasons tend to work. It would be unusual for any day in the summer in Melbourne to be cold, or any day in the winter to be especially hot, let alone for the average of any January to be cold or any July to be hot there. But this isn't the same for wet seasons. There's no months-long period of rainfall in the same way that there can be a months-long period of hot days. Even the rainiest months in the rainiest places peak out at around 18 days with precipitation, and there are even some years when a dry month in one of these places gets more rain than a wet month. But for the sake of definition, these seasons exist based on the average total rainfall for each month. In Jakarta, the peak of the wet season is around January and February, with the dry season running from June to September, as there's about 8 times as much rain in February as there is in August. But even without leaving Indonesia, you can find places where this trend is essentially reversed. Like in northern Sumatra, where August tends to have more rain than February. There's also a lot of variation in the size of the difference between the wet and dry seasons. Throughout Indonesia, even in the dry seasons, there's still a fair amount of rain. But if you go to the rainiest place on Earth, the state of Meghalaya in India, during its dry season you won't find any rain. Whereas there can be meters of rain each month from May to September, the average rainfall in December is less than a centimeter, which is comparable to the rainfall in a desert city like Cairo or Las Vegas. And I haven't even mentioned that in some places, particularly in East Africa, there are 2 wet seasons, with a few drier months in between. But why? I think all these facts make a bit more sense when you look at all these points together in the context of the global water cycle. So here's an animation showing the average total rainfall of each month around the world, based on the CHELSA dataset, a gridded model of monthly climate from 1979 to 2019, synthesized from a mix of remote and ground-based sources. On any given day, clouds and storms may form and break up anywhere, but this is the average, revealing the underlying heartbeat of the Earth's water. The path highlighted in gold here is the Intertropical Convergence Zone, or ITCZ, the place where the northern and southern Hadley cells meet. As warm air rises near the equator, a low-pressure zone is created near the surface, sucking in moisture as the trade winds converge from the north and south. The circulation is relatively stable throughout the year over most of the oceans, as water holds heat fairly well, but over land, the Hadley cells in ITCZ move much further, creating a belt of clouds that runs up and down across Africa throughout the year, bringing rain to the Sahel from March through October and to much of southern Africa in the other half of the year, at the same time that the Harmattan wind blows dust and sand south from the Sahara into the Sahel. Meanwhile, parts of East Africa get run over by the ITCZ twice, creating systems of 2 distinct wet seasons in places from Kenya to Ethiopia. The Indian Ocean also has a strong asymmetry, due to the arrangement of the continents, so in South Asia, monsoons whip across the continent in the summer like a wave converging into a corner, before just as quickly flowing out. Outside the tropics, an inverse of this effect can be found where the Hadley cells meet the mid-latitude Ferrel cells. The dry, high-pressure zone between them, sometimes called the horse latitudes, migrates north to Europe in the summer, creating the distinctive Mediterranean climates found around 45 degrees from the equator, where the summers are dry, but the winters are wet, the opposite of what it is in most places closer to the equator. Each of these cycles are just individual gears in the global atmospheric circulation, a circulation that's chaotic and complex, but which has a few general tendencies. For the most part, wet seasons peak around the time of the summer solstice for that hemisphere, though, as we've seen, there are plenty of exceptions. So I'm coloring in this map by what month has the highest average rainfall. You can find places where the wet season peaks in March in northeast Brazil, November in the southern Congo, and all 12 in Indonesia. So what about North America, where I grew up? Well, as it turns out, there's a large stretch of the eastern US where the rainiest month is none of them. Because this region happens to have some of the least significant seasonal rainfall variation in the world. For the land highlighted in gray on this map, the month that's usually driest regularly gets more rain than the month that's usually wettest does on average, which is actually really weird from a global perspective. Ignoring deserts, there are only a handful of regions that don't have consistent wet and dry seasons. These are parts of New Zealand, New South Wales, the Cape of Africa, Borneo, and Uruguay, and in the eastern US and Canada, Western Europe, and the Eurasian steppe. There's an interesting pattern in these places. The cores of the major British and French settler colonies all lack seasonal rain, just like the UK and France themselves. That's no coincidence. Similarity in climate and, by extension, the transposability of farming techniques played a role in the dynamics of the colonial era. So, if I may permit myself to engage in a little speculation, I wonder if this is the reason why these colonies were set up where they were. If some faraway land happens to have the same climate and seasonal patterns as where a settler came from, then their methods of agriculture, their way of life, will translate more cleanly onto these lands in particular. Which means that a mere coincidence of climate hundreds of years ago determined whose lives got uprooted, whose lands got taken by who, and what languages would be spoken where in the modern period. Maybe this is why the Dutch and British settled the Cape of South Africa more than any of their other colonies on the continent, and why the US and Australia alike got colonized first with farms in the east before being colonized with mines in the west. And perhaps it's why, as an indirect consequence, across the English-speaking world, rain just isn't thought of as a seasonal thing. We don't have the words for it, or connotations of raininess baked into the names of the seasons outside of specific regions. But for almost everywhere else, rain is undeniably seasonal. For 91% of the world's land, the wettest month of the year has more than double the average rainfall of the driest month. Overwhelmingly, seasonal rain is the rule, and the eastern US is strange for having such a large region without it. But I will note that here, as well as further into the interior and along the southeast coast, where the summer is meaningfully wetter than the rest of the year, there is still a decent amount of rain in the spring, so while April isn't a rainy month per se, it's not necessarily a dry month either. There just aren't any spots where it's exceptionally wet. So how did April become the month of showers? Well, we shouldn't expect to find the answer in the US. This rhyme, which this whole idea is based on, isn't from the US. It's from the UK, which, if my research is correct, is on a different continent. So, of course, the seasons work a bit different there. There's a post on the Rochester First Weather blog that points this out, and clarifies that April for the UK is one of the more soggy months based on the position of the jet stream. So, is that true? Well, as I've already said, no, but it is notable that in much of Europe, the winter has more rain, the defining trait of the so-called Mediterranean climate. It's a relatively rare classification found in parts of Australia, South Africa, Western North America, and, as the name implies, the Mediterranean. This still doesn't explain the rhyme, though, given 1. April is no more a winter month than it is a summer month, and 2. The UK is notably not in the Mediterranean and doesn't have a Mediterranean climate. Sure, there are places in the Mediterranean where the wet season extends into spring, such as Gibraltar, where April showers bringing May flowers is honestly a perfectly adequate description of the transition from spring to summer, but for the parts of the empire that are actually in Britain, April is no soggier than any other month because all the months there are soggy. It is a soggy place full of soggy people, and April is, if anything, one of the less soggy months. But we're still not done here. What is a shower, actually? See, showers aren't just any rain. A shower is a brief period of intense rainfall. And April, says AccuWeather.com, has more showers than other months, even if there's not more rain in total. They even tell us why this happens. Once again, the jet stream, or more specifically the northern polar jet stream, which they point out moves to higher latitudes in the spring, resulting in an air pressure gradient that spawns cumulus clouds and, in turn, rain showers. Which, if true, implies that April showers aren't a uniquely British phenomenon. They should exist everywhere crossed by the northern polar jet stream. But I can't help but notice that, while AccuWeather staff was rather precise when talking about rainfall averages, their discussion of showers is more vague. I had trouble finding anybody who went more in depth than this. The BBC, Missouri State, all of them give this basic summary. There's never any calculation or sources I can check, just the assurance that this is a real phenomenon and this is why it happens. They answer the why before the if. So, while this jet stream idea makes theoretical sense, it's still just that, theoretical. There's no maps or numbers. I'm back to where I started. So, I must ask, what exactly is an April shower? Trying to find scholarly work on the subject brings up a lot of titles that have nothing to do with weather, but use the term April showers for poetic effect. Like, April showers bring May flowers, an article about the Indiana legislature's schedule. Or, April showers cause CLL and myeloma to flower, which is about multiple myeloma and references the protein called April. In fact, in all my searching, I only found one article that actually uses the words April showers to describe a meteorological phenomenon. On the surface of Titan. But, of course, I shouldn't be looking for papers about showers. The terms to search for here are convective and stratiform precipitation. These are categories that describe the cause of the rainfall, but there's a tendency for convective precipitation to come down harder and end sooner than stratiform. In other words, it fits the definition for a shower. That is oversimplifying it, but by looking at some radar returns from satellite data, maybe we can find evidence of AccuWeather's claim. See, the difference in droplet size distributions in convective and stratiform rain affects the radar reflectivity at different frequencies. So, using some algorithms, one can figure out what fraction of the rain comes from what kind of source. And here are some maps from a paper by Song Yong and Eric Smith using data from the Tropical Rainfall Measuring Mission, or TRMM, that show that over North America, Europe, and West Asia, the majority, around 60% of the rainfall is convective during the summer months, and during the winter months, the reverse is true. Around 60% of the rainfall is stratiform. The reason for this is straightforward. Warmer temperatures mean more convection, and thus more convective rain. So, summer is the season of showers, at least in these parts of the world, and AccuWeather is wrong, at least in the breadth of their claim. The Tropical Rainfall Measuring Mission doesn't have data for higher latitudes, leaving out a big chunk of the planet. But with the TRMM deorbiting in 2015, its replacement, GPM, standing for Global Precipitation Measurement, was launched in 2014, and its orbit lets it cover 140 degrees of latitude. So, aside from the Arctic and Antarctic, I can look at these same ratios in the northern areas where the jet stream should cause April showers, and it doesn't. Perhaps this is a bad way to look at this. Radar returns are only a proxy for rainfall type, and rainfall type is only a proxy for what should be called a shower, so what if we could just count showers directly? Well, if you're willing to look at one city at a time, METAR records are a good source for historical weather patterns. So I pulled some METAR records from a few airports around London via the NOAA NCEI's Integrated Surface Database. METAR, for the uninitiated, is a format for recording weather at airports in a way that's helpful for aviators needing to take off and land. So it includes information like the ICAO airport code, the time of the observation, wind speed and direction, visibility, cloud cover, temperature, and what I'm most interested in, the current precipitation. There are a bunch of different codes for types of precipitation, including things like snow, smoke, or volcanic ash, but it also makes sure to differentiate rain, drizzle, and showers. Though showers here is actually a descriptor attached to the precipitation type, so while rain showers are common, it can also be used to indicate showers of snow or hail. So if I count up how many days feature rain or drizzle, and compare that to how many feature specifically rain showers or drizzle showers, we can see which month actually has the most showers. So here's the averages for London Heathrow Airport over the past 10 years. The month with the most showers is August. Just barely. In terms of raw number of showers, there's very little difference throughout the year, but in terms of the proportion to other rainfall, there's a very real trend of showers being more prominent in the summer, while continual precipitation is slightly more common in the winter. Exactly what was indicated before by the radar data. This isn't a big difference. There's only about 45% more showers in the showeriest month than the most showerless, and that's after you adjust for total rainfall. But it is a statistically significant difference, which for science is what really matters. Looking at another airport, say Stansted, we find a similar trend, though with considerably less showers throughout the year. Though the rainfall counts are almost exactly the same as in Heathrow, which would imply that there's something different about the weather here that causes it to get less showers. Except Stansted is not on the other side of the UK, it is 40 miles away, so how can this be? Well, it's because, to my great annoyance, the METAR format does not actually have a clean, consistent definition for what a shower is. The World Meteorological Organization's technical regulation, in fact, does not give a definition, only recommending that precipitation not be characterized with showers by automated systems if it can't be determined based on a method that accounts for convective cloud cover. Adding that to the fact that the METAR format itself has gone through several different iterations over the decades and has different standards in different countries, the results of any shower analysis I attempt come down to the arbitrary methodology of who made what reports and when. We can see this especially well by breaking down the data by year. It looks like the showers just stopped about 9 years ago, when in reality it's just that the methodology was changed in October 2015. And so, while I could conclude that in Britain, stratiform precipitation dominates the winter and cumuliform precipitation dominates the summer, and so while April isn't the peak of any season of showers, it is when it starts, I have to ask, am I missing the point? Were AccuWeather and Missouri State and the BBC all missing the point? Is this really what was meant by this poem? April showers bring May flowers? To find out, let's take a look at the history of the poem, so we can understand who wrote it and why. The earliest usage of the exact wording April showers bring May flowers, at least that I could find, is in the book Astrologia Restaurata, written in the 1650s. Even here, it's already described as an Old English proverb, but notable to me is the emphasis it places on how the April showers bring the May flowers. Because this is true, at least on a basic level, water is required for germination, alongside conditions of temperature and light for annual plants. So a way to predict when many flowers will begin to grow is by looking for the first rainfall of the year that comes at a time when it's finally getting warm again. In other words, April. Though, of course, rather than attributing this to the jet stream, it's blamed on the stars and the southern wind, which I'd like to get back to later, so put a pin in that. An earlier version of the phrase can be found in Thomas Tusser's 1573 work, 500 Points of Good Husbandry, a book of farming wisdom told entirely through couplets, which features sweet April showers do spring May flowers. But even this is probably not the origin of the expression. That, if it is from literature, as opposed to being an untraceable proverb, may be the Canterbury Tales. Its first lines, in fact. One that April with his showers suit, the drought of March has pierced it to the root, and bathed every vein in switch liqueur, of which vertu engendered is the flower. In other words, sweet April showers pierce the drought of March, bathe every vein, and bring flowers. But I'll note that it's just as much about the drought of March as it is the sweet rain of April. So one reading is that April's rain is sweet in the way that an occasional dessert is. In other words, it's sweetened by its rarity. But I'm even more interested by the next 4 lines. One Zephyrus eke with his sweet breath, inspired hath in every holten heath, the tindra crops the youngest sun, hath in the ram his half-course run. Chaucer makes reference to Zephyrus, the Greek personification of the west wind, a wind that has much older ties to the start of spring. Not through Greece, mind you, but Rome, where year after year the west wind starts to pick up around March and dominates the summer. They called it Favonius, the favorable wind, and said that he was married to Flora, the god of, well, you can guess. But the myths around this wind, and its connections with spring, and the character of the favorable gentle rain, are certainly what Chaucer was making reference to, just as Tusser made reference to Chaucer's sweet April showers, and just as those posters of the months made reference to that. In other words, it's a meme. This whole time it's been a 600-year-old meme. Without tracking the weather and knowing the meteorological context that inspired the myths of the Zephyr, I have to wonder if Chaucer had any idea that the tale he was painting was inaccurate to, England, as he put it. In writing this script, I've talked with several people from the US who really had thought that April was a rainy month, and had never considered whether that was true or where the idea came from. Which got me thinking, if it's so easy to go your entire life living in one place, but not getting a basic understanding of what the seasons are like there, then what else might I have missed? In all of this, I haven't touched on the idiomatic meaning of the expression. April showers bring May flowers. It means difficult times come before good times, and even bring them into being. That is perhaps the more important lesson here, even if I personally chose to focus on the meteorology. The truth is, I just wanted to talk about wet seasons, and I probably am going to rename this video to something like that in a couple days, just because I am uploading this at the end of April, which maybe that wasn't ideal. But yeah. By the way, this website that I'm clicking around on is on my personal blog page. I will leave a link to it in the description. It lets you view just the average seasonal temperature, precipitation, and even vegetation anywhere in the world with a few different maps I've created on here. I think it's neat. But I'm also aware that a lot of the people who are subscribed to this channel did so because of astronomy videos, so the next video will be about astronomy. But until next time, enjoy the Mayflowers.